Here's another application of factoring. Using factoring to find the least common multiple of two numbers. A multiple of a number is that number times something. The multiples of 5 are 5, 10, 15, 20. The multiples of 7 include 21 and 77 and things like that. Anyway, the least common multiple of two numbers is the smallest number that is a multiple of each. It's the first number times something, it's the second number times something, it's the smallest number that has that property. Now, I have invented this game I call the fairness game, or giving kids stuff to make them happy. Let's do a couple examples. This game is, with factoring, we'll find least common multiples. Let's suppose you have two kids, I don't know, Kim and Mike. Okay, Kim and Mike are siblings. Kim's mother gives her 2 hearts and a smiley face. Mike's mother gives him 1 star, 1 heart and 3 stars. Are these kids happy? No freaking way. Why? Mike got 4 things, Kim got 2 things, Kim got more hearts, Mike didn't get any smileys. There could be a lot of unhappiness in this household. So the question is, what do you have to give them to make them happy? And what does it mean for kids to be happy? They have to have the exact same things. Kim's looking over there at those stars and she says, I'm going to need 3 stars or I'm going to throw a fit. So we give Kim 3 stars and now she's happy. There's nothing that Mike has that she doesn't have just as much of. Mike's not happy. He only got 1 heart. She got 2. So he wants a heart. And he didn't get any smiley faces. He wants a smiley face. And now they have the exact same thing. They both have 2 hearts, 3 stars, and a smiley face. It's not the hardest game to play. And in fact, if we just went back to what they originally had, the 2 hearts and the smiley face, the heart and the 3 stars, and we played the what they have in common game, that's not the thing I want. I want this. What do they have in common? If we were playing greatest common divisor, the greatest common divisor would be a heart, see? And you would notice that the things that they don't have in common, the 3 stars, is what Kim wanted, the heart and the smiley face is what Mike wanted. So it's not the hardest game of all. And this game is exactly what we use to find the least common multiple. Let's do 2 examples. An easy example, find the LCM, least common multiple of 15 and 18. 15 and 18. What do we do for 15 and 18? 15, we factor. 15 is, we can do this in our heads, 3 times 5. That's what it is. That's the fingerprint of 15. 18 is, 3 times 6? 3 is a prime number. 6 isn't. 6 is 2 times 3. So what are we looking at? We're looking at one has a 3 and a 5. One has 2 3s and a 2. So what are they going to be jealous of? Well, one thing is, what do they have in common? What they have in common is just the 3. So what does 15 over here on the left, what is it jealous of? It wants a 2 and it wants a 3. It wants the things that it doesn't have. And in fact, we're done. If we wanted to do it for the 18, we'd say it's jealous of the 5. It wants a 5. But all we need to say is that the LCM of 15 and 18 is 3 times 5 times 2 times 3. What is this number? It's always easiest to make tens first. 5 times 2 is 10. 3 times 3 is 9. 9 times 10 is 90. So 90 is the smallest number that is a multiple of 15 and a multiple of 18. It's what? It's 15 times 6. It is 18 times 5. And so if you're one of those people that goes grocery shopping every 15th day and who bathes every 18th day, then every 90 days you're going to bathe and go grocery shopping. It's kind of hard to come up with real-life applications for this sort of stuff, but that is kind of nice. I'll do one more example just to kind of emphasize a lot of the things that we've been doing today. I don't even know what day today is. Let's say we want the least common multiple of 45 and 126. Oof, 45 you should be able to factor in your head. 45 is what? 9 times 5. 9 is 3 times 3, and then there's the 5 that we want, the 5 that we had. 9 times 5, that's 45. 126, oof. 126 ends in it's an even number, so we can divide it by 2, and that's 2 goes into 12, 6, and then 3. No longer an even number. 6 plus 3 is 9. That number can be divided by 3. 3 goes in 21. 2 plus 1 is 3. That can be divided by 3. Remainder of 7. 7 is prime. So what have we got? We've got 45 is that, and 126 is 2 times 3 times 3 times 7. And, okay, so what? It's like Kim got 2 3s and a 5, and Mike got 2 3s, a 2, and a 7. Well, Kim wants what? Kim wants a 2 and a 7, and Mike wants a 5. Or you look at it and you say, what do they have in common? They both have a 3, they both have another 3. That is to say, 3 times 3, 9 is the greatest common divisor. It's the largest number that divides 45 and divides 126. But we've also figured out that the least common multiple is 3 times 3 times 5 times 2 times 7. And this is surprisingly useful. This is the first number that's a multiple of 45 and a multiple of 126. It's 45 times 14. It's 126 times 5. It's a multiple of both of them. Very useful trick. And while I have this machine running, why don't I say one more application of factoring? If I take two large prime numbers, fairly large prime numbers, it's a totally different topic. Let's say 43 times 73. I've got a calculator over here. I'm not going to break it out on the screen, but 43 times 73 is 3,139. If I asked you to factor 3,139, you'd probably be sunk. In fact, if you asked me to do it, I would be sunk. Because what? It's not even, it's not divisible by 5, because it doesn't end in a 5 or 0. If you add up all the digits, 4, 7, 16, not divisible by 3. No, it's divisible by what? It's divisible by 43 and 73. How many prime numbers are you going to have to try? I mean, what are the prime numbers? 2, and then 3, and then 5, and then 6, 7, 8, no, 9. A lot of people think 9 is prime. It's not. It's 3 times 3. Oh, and 1, not prime. 1 is not prime. 9, 10, 11, and then 12, 13, 14, 15, 16, 17, and 19. I mean, you'd have to try all of these numbers until you got up to 43, and you're like, oh, 3,139 is evenly divisible by 43. This is a pain in the butt. Factoring is a pain in the butt. And in fact, a huge application of this is when you buy something online, when you send a secret, basically, you want to use, a secure connection. You are doing what? You are encoding the information. You are using a code. You are encrypting your data. What they do is they take two large prime numbers and they multiply it together. And it's a bit well beyond the scope of this course, but they encode the data using these two numbers. And then they use this as well. If you are able to factor this number, then you can read the data like a breeze. It is so easy to take the encrypted message back if you know how to factor the numbers. But if you can't figure out how to factor this number, then it is a really, really hard problem and you can't read the message. The government uses this. Everybody uses it. This is the heart of all computer security, basically all codes these days. This is it. Of course, if you're sending military data, or even with the computer, what they do is they don't use 2-digit prime numbers. They use 100-digit prime numbers, or probably the CIA is probably using 120-digit prime numbers. If you multiply a 100-digit number times a 100-digit number, you get a 200-digit number. And if you sat there looking at that 200-digit number thinking, it's not divisible by 2, it's not divisible by 3, it's divisible by some obscure 100-digit long prime number. And it could take lifetimes with the fastest computer in the world to try to break that number down. And in fact, when I was a kid, there was this nuclear arms race. The U.S. and the Soviet Union was trying to compete to see who could come up with more nuclear and better nuclear weapons. We had really clever ones. They had big ones that would just take it. Even if they missed, they'd still kill you. Nowadays, we are competing with prime numbers. We are factoring numbers. We are finding slightly better procedures for factoring prime numbers because this is what's keeping our secret secret. This is what is protecting your credit card information when you buy things online. It is the difficulty of factoring numbers.